Hello and welcome. So today I'm going to be talking about CDNs. I'm going to be talking about when to use them and how to avoid issues. So the first question is, obviously, what is a CDN? So a CDN is basically a server that serves static content for an application. And so static content is basically something that doesn't change a lot. So like images or videos, etc. Essentially, when you're looking at a website, for example, you might have something like a news article. The content in the article is going to change all the time, but the CSS really is only going to change when you actually change the code, which isn't anywhere near as frequent. Same thing with like images. The images themselves, typically once you upload an image, it's just uploaded. So that's going to be a static content as well. So why should you use them? Well, they're super cheap. Because they don't have to do any sort of processing, they are really cheap to set up because they don't need a ton of resources. They're super fast because you can basically store everything that you want to kind of get going in the CDN itself. So instead of having to load the information from disk with a server, so you have to load it from a hard drive or something like that, what you can do with CDNs is just keep everything stored in the RAM, which is significantly faster. On top of that, they're also really easy to integrate. You don't really have to do anything extra to start using them. Basically, anywhere that you would have normally put a link to a file, you basically just swap that around with the CDN link instead. So, what are some use cases? Well, basically, if you need something to load faster, this is probably going to be what you need to do. If it's static content, for example, you have big images or a ton of videos, this would be where you want to use a CDN. In the article linked below, there's actually some information about Netflix and how they started using CDNs to make their system a lot faster. You can also expand internationally using them. Basically, because they're so cheap, you can deploy a whole bunch of them in different countries and then just have them all pull from one main server, and then your static content loads really a lot faster essentially in those countries. And also to provide more than one point of failure if you have a server, because then obviously all the CDNs have to go down before you lose access to it. And there is one more really important one, which is using them for JavaScript, or just using them for code in general. So code is another great option because it doesn't really change very much. Your CSS and JavaScript don't tend to change that much. It can benefit obviously from loading faster because your browser has to first load it and then parse it and do all that stuff. And also setting up JS distribution is much easier because you don't need to set up npm and install it into your project. So what's the problem? Well, you're basically loading files from another server that you don't necessarily own. If you're loading something from a server that you've called let's say ignitecdn.com, for example, and that was owned by another company, how do you actually guarantee that the user has the same files that they're supposed to get when they actually load them in the browser? If somebody uploads some malicious code, basically our users suffer the consequences. So here's a good example. So we have file.js, which is supposed to be just a hello world console.log. We then have badfile.js. This basically asks somebody for their password, and then in this case, the console.log at the end would be replaced by something to actually steal that password. And then in our index.html, we load that in as a script source, and we just kind of hope that file.js is the regular file that we wanted instead of bad file. So what do we actually need to try to avoid this problem? Well, first of all, we need to make sure our code's correct before we run it, but how do we actually know it's bad without running it? We could analyze it, but that would be super slow. We basically have to go line by line and check that information. If we include that in the HTML anyways, why don't we just include the file directly inline in the HTML at that point for starters, if we're going to do that? And we basically lose out on all the advantages of having a CDN, and we basically just have a problem. So how do we actually get over our trust issues? So what we need is something that's faster than reading a file. We need something, that's reading the file content and actually parsing it. We need something that takes up less space than having the file content on the page. And we need something that we can include in our HTML easily. And so hashing is basically a system that's been used for ages. It's not only used for doing this sort of validation stuff, it's used for a whole ton of things. If you've ever used a dictionary in Python, or you've used a JSON object, there's a lot of stuff with hashing there called hash maps that are interesting to look at. But basically, you stick some stuff into an algorithm, and you get an output on the other side. But the important thing is that what you stick into the input of an algorithm will give you the exact same output at the end. And so what that means is that if you put something that's different in, you'll get a different output. And so basically when you run something through it, you can just check to see if the output is the same as what you were expecting. So SHA-1 is a super popular set of, so SHA is just generally a superset of a whole bunch of different hashing algorithms. SHA-1 is a really old one that people use. It basically takes in any input size of characters, so you can take in 100,000 lines or whatever you want, and then it will output out 40 characters. It's super fast, and it always has the same output, which is sort of true. See the actual article in the description for more details about SHA-1 and about some of the details with some of the security issues with SHA-1 as well. But here's what the example would look like. We take our console.log file, we run it through SHA-1, we get 40 characters at the end, exactly 40 characters. You can see them at the bottom there, 865, whatever, right? We then have our bad file, which we put in, and we still get 40 characters, the exact same length, but at the bottom, you can see it's a different hash at the bottom there. And so when we put this in our HTML, we can include what's called an integrity hash. And so you can see that integrity basically has a thing that says SHA-1 at the beginning, which tells it what hashing algorithm you're using, and then the actual hash at the end. So it knows, okay, when I ask Ignite CDN for this file, I need to first run it through SHA-1 when I get the content back, and then check if it matches the hashes at the end there. And that cross-origin anonymous is also explained in the article in the description as well. So here's an example. We have a situation where we have the bad file, right? So the client basically requests the Ignite CDN and it requests for file.js. We then have that request gets responded back with contents of file.js. Our browser, with that returned content, basically goes through, runs the SHA-1 algorithm, which then gives it back a hash. And from there, we compare the hash to the integrity hash. If it matches, we tell the browser to execute. If it doesn't, then there's a couple of options. We can either retry to try and get it again from the server, or we can throw an error and just error out from there. So, thank you for watching. If you want more details, check out the full article in the description below.